you're lost. No GPS, no compass, no landmarks. Just endless sand stretching in every direction under a black sky. The temperature has dropped from scorching to freezing in hours. Your water is running low. One wrong turn means death. But the Bedouins? They never got lost. Not once in over 1,000 years of crossing the most brutal deserts on Earth. While you're panicking, checking your phone for signal, praying for a satellite connection, they would simply look up. The stars weren't decoration to them. They weren't poetry or mysticism. They were a navigation system more precise than anything humans had created until the age of satellites. And they carried it all in their heads. The desert at night is a different planet. The same scorching wasteland that burns flesh during the day becomes a freezing void after sunset. Temperatures can plummet 30 degrees Celsius in just a few hours. The sand that blistered your feet at noon now feels like ice against your skin. But for the Bedouins, darkness wasn't the enemy. It was their greatest ally. The night didn't bring danger, it brought direction. In daylight, the desert is chaos. Dunes shift with every sandstorm, erasing yesterday's landmarks. Rocks look identical from different angles. Mirages twist reality, showing lakes where there's only burning sand. Water sources dry up without warning. Oases that saved your grandfather's life might be buried under 20 feet of sand when you arrive. The day desert lies. It tricks. It kills with false promises. But the stars? The stars never lied. For over a millennium, Bedouin navigators used the night sky like a living map, precise, reliable, and always available. They didn't just know a few bright stars like modern campers pointing out the Big Dipper. They memorized the entire celestial sphere. Every star had a name. Every position had meaning. Every movement told a story about direction, season, time, and weather. These weren't simple directions like north or south. Bedouin star navigation was surgical in its precision. They could tell you north-northeast by east. They could guide a caravan to a specific well 300 kilometers away across completely featureless desert. They could predict their arrival time down to the hour, days in advance. And they could do it all without ever writing anything down. The knowledge was passed from father to son, from elder to apprentice, across generations. Not in books or charts. Those would be destroyed by sand and heat within months. But in memory, in songs, in stories that encoded astronomical data so precisely that modern astronomers are still amazed by their accuracy. Young boys would spend years learning to read the sky. They'd start by memorizing the brightest stars, then the major constellations, then the subtle movements of star groups across seasons. By the time they were men, they could navigate by stars so faint that city dwellers today would never even notice them. Their night vision was trained to see celestial details that would be invisible to most modern humans. This wasn't casual knowledge. In the desert, navigation errors didn't mean inconvenience. They meant death. A caravan that missed its water source by even a few kilometers could lose every man, woman, and child. A trader who miscalculated his route could watch his camels die of thirst while the correct path lay just beyond the next dune. The stakes were absolute. The precision had to match. The Bedouins developed one of the most sophisticated astronomical navigation systems ever created by humans. More complex than what Viking sailors used to cross the North Atlantic. More precise than what Polynesian navigators used to find tiny islands across thousands of miles of open ocean. And they did it in the harshest environment on Earth, where a single mistake could erase an entire bloodline. No telescopes, no instruments, no computers calculating stellar positions. Just pure observation, refined across centuries into a system so accurate that when European explorers arrived with their brass sextants and magnetic compasses, they often found that Bedouin star navigation was more reliable than their mechanical tools. The desert nomads had turned the night sky into a three-dimensional map overlaid with time zones, weather predictions, and seasonal calendars. They could read not just where they were, but when they were, what was coming, and exactly where they needed to go. Every star that wheeled overhead was a data point in a navigation system that kept entire civilizations alive in places where nothing else could survive. But this knowledge came with a cost. Learning Bedouin star navigation meant dedicating your entire life to watching the sky. Night after night, season after season, year after year, until the movement of the stars became as familiar as your own heartbeat. Until you could wake up at any hour and instantly know your position just by glancing up. Until the celestial sphere became your second home, more reliable than Earth, more constant than water, more trustworthy than any human guide. Modern humans look up at the night sky and see beauty. The Bedouins looked up and saw survival. They saw the difference between life and death written in points of light so distant that their illumination had traveled for centuries just to reach their eyes. And in that ancient starlight, they found the knowledge that let them thrive where others perished. The foundation of Bedouin navigation wasn't Polaris, the North Star that guides navigation in northern latitudes. In the southern Arabian deserts, in the vast stretches of the Sahara, Polaris sits too low on the horizon to be reliable. Sometimes it's hidden behind dunes. Sometimes it's obscured by the heat shimmer that persists even at night. The Bedouins needed something better, something more sophisticated, something that would work anywhere in the desert, at any time of year. Instead of relying on a single star, they built their entire system around the movement of star groups across the sky. They understood something that wouldn't be formally recognized by European astronomy for centuries. The celestial sphere is in constant motion, and that motion can be read like the hands of a cosmic clock. The key was the Manazil al-Qamar, the 28 lunar mansions. These were specific star patterns that marked the moon's path through the heavens over the course of each month. But the Bedouins didn't just use them to track time. They used them as compass points, carved across the dome of the sky with mathematical precision. Each mansion rose in the east at a precise time and season. As the earth rotated, the stars wheeled overhead in perfect, predictable order. By knowing which mansion was rising, which was at zenith, and which was setting in the west, a navigator could determine not just direction, but exact direction. Not just north, but north-northeast by east. Not just southeast, but southeast by south half south. Precision that could keep a caravan on course across 1,000 kilometers of unmarked desert. The system was based on the fundamental truth that the stars are punctual. Sirius rises at exactly the same time each year. The Pleiades reach zenith at precisely the same hour each season. Orion sets in the west with clockwork regularity. What changes is your perspective, your position on Earth, your time of observation. By reading those changes, by understanding the relationships between star positions and earthly location, the Bedouins could triangulate their position with stunning accuracy. The brightest stars got special names and specific navigational roles. Aldebaran, the follower, marked true east when it rose before dawn in autumn. Al-Simak al-Rami, the unarmed one, pointed to magnetic north when directly overhead. Suhail, known to Western astronomy as Canopus, announced the end of summer heat when it first appeared on the southern horizon each year. But it wasn't just about individual stars. The Bedouins read relationships. Angles between stars, the spacing of constellations, the tilt of star groups relative to the horizon. When the Great Bear stood vertical in the northern sky, they knew the direction and strength of the prevailing winds. When Orion's belt aligned perfectly with the eastern horizon, they could predict the exact moment of dawn hours in advance. When the Pleiades disappeared in the sun's glare, it meant the season for long desert journeys had begun. They developed mental maps so detailed that a skilled navigator could determine his position within just a few kilometers, simply by looking up. No instruments needed. No calculations with pen and paper. No charts or tables. Just a lifetime of watching the sky turn overhead, night after night, until the patterns became as familiar as the landscape of his own tribal territory. The precision was staggering. European explorers in the 18th and 19th centuries, armed with the best chronometers and sextants their technology could produce, would often find themselves lost in the desert, while their Bedouin guides maintained perfect course headings using nothing but naked eye observations of the stars. But learning this system required more than memorization. It demanded understanding the three-dimensional relationships between celestial objects and how those relationships changed over time. A Bedouin navigator had to visualize the entire celestial sphere as a rotating dome overhead, track the seasonal variations in star positions, and account for the subtle differences in stellar visibility at different latitudes. They learned to compensate for atmospheric refraction, the way stars appear slightly higher in the sky than their true positions due to the bending of light through air. They understood that stars near the horizon couldn't be trusted for precise navigation because of this distortion. They knew which stars were reliable for direction finding and which were better for timekeeping. The training began in childhood. Young boys would be taken outside every clear night and tested on star identification. They'd learn the stories behind each constellation, not as entertainment, but as mnemonic devices that encoded navigational data. The myth of the hunter wasn't just a tale to pass time around the fire. It was a memory palace that contained precise information about seasonal star movements, optimal travel times, and directional references. By adulthood, a trained navigator could perform feats that seem impossible to modern minds. He could determine the exact hour of the night by observing which stars were rising. He could predict weather patterns days in advance by reading subtle changes in stellar visibility. He could guide a trading caravan across hundreds of kilometers of featureless sand and arrive at a specific oasis at a predetermined time. The star knowledge wasn't separate from other desert skills. It was integrated with everything else needed for survival. Astronomy connected to meteorology. Navigation linked to animal behavior. Star positions correlated with seasonal water sources. The night sky became a comprehensive database of survival information, accessible to anyone who had invested the years needed to learn its language. Navigation wasn't just about knowing star positions. It was about reading time itself, slicing the night into precise segments, each marked by stellar movements that repeated with mathematical certainty. The Bedouins didn't just know that Orion pointed south. They knew that when Orion's belt was exactly 2 hand-widths above the eastern horizon, it was precisely 4 hours after sunset. When it reached zenith, dawn was exactly 3 hours away. They divided the night into segments as precise as modern time zones. Each segment was marked by the rising, transit, or setting of specific stars. They could tell you not just the hour, but the fraction of the hour. Not just whether it was early or late in the night, but exactly how many minutes remained until dawn, until optimal travel time, until the moment when stellar positions would shift enough to require course corrections. The critical skill was interpolation, reading the spaces between known positions. If a key navigation star was halfway between the eastern horizon and zenith, that meant specific time and direction readings. If 2 bright stars formed a particular angle with the horizon, that indicated precise compass bearings. Every night, the sky became a vast instrument panel, displaying dozens of navigation readings simultaneously. A skilled navigator could dead reckon for hours using just the memory of his last stellar fix. He'd count steps, estimate speed, feel the subtle variations in ground slope that indicated drift from the intended direction. He'd monitor wind direction, sand texture, even the behavior of his camels for clues about terrain and proximity to water. When the sky cleared again after cloud cover, he'd check his position against the stars and find himself still precisely on course. Weather added layers of complexity that separated master navigators from apprentices. On cloudy nights, they used gaps in the cloud cover like windows into the navigation system above. Even a small patch of visible stars, just a few degrees of clear sky, could provide enough information for a position fix. They'd identify the brightest star visible, determine its exact position relative to the cloud edges, and calculate direction and time from that single reference point. During sandstorms, when the sky disappeared entirely behind walls of flying dust, they relied on techniques learned during clear nights when they could verify their accuracy against star positions. Wind direction was crucial. Sandstorms in the Arabian Peninsula follow predictable patterns, and experienced navigators could maintain course headings by reading the direction of sand striking their faces, the sound of wind against their robes, even the way their camels leaned into or away from the storm. They learned to use their bodies as instruments. The span of an outstretched hand at arm's length covers exactly 15 degrees of sky, 1 hour of stellar motion. The width of a finger covers 1 degree, 4 minutes of time. By measuring star positions against their own hands, they could determine precise celestial coordinates without any tools except their own anatomy. The most challenging aspect was maintaining accuracy over multiple nights of travel. Star positions shift slightly each night due to Earth's orbital motion around the Sun. What rises at midnight in September will rise 4 minutes earlier each successive night. Over a week-long journey, these small changes accumulate into significant navigation errors unless compensated for. Bedouin navigators learned to adjust their readings automatically, like musicians who can hear when an instrument drifts out of tune. Young Bedouins learned through constant testing and repetition. Elders would wake them at random hours and demand immediate position readings. They'd cover known landmarks with cloth and ask apprentices to navigate by stars alone to specific destinations. They'd create artificial challenges, navigating during the few minutes of clear sky between cloud banks, finding direction when only the faintest stars were visible, maintaining course when wind and sand obscured all normal reference points. The training was relentless because the consequences of error were absolute. A caravan that drifted off course by just a few degrees could miss its water source by dozens of kilometers. In the desert, there's no room for close enough. Navigation had to be perfect, or everyone died. Star knowledge was tested not just for accuracy, but for speed. A navigator had to be able to determine direction and time within seconds of looking up. Hesitation meant uncertainty. Uncertainty meant doubt. And doubt, in the presence of men whose lives depended on your guidance, could destroy the confidence that held a caravan together. The system also had to account for seasonal variations. The same star that provided perfect navigation in winter might be completely invisible during summer months. Navigation routes that worked during certain seasons became impossible during others. A master navigator needed to know not just where the stars were tonight, but where they would be next month, next season, next year. They developed backup systems within backup systems. Primary navigation stars, secondary references, tertiary confirmations. If clouds obscured the main star group they were following, they knew which alternative stars would provide the same information. If sandstorms lasted for days, they knew how to navigate by sound, by wind, by the behavior of their animals, until the sky cleared enough for stellar observations to resume. The most skilled navigators could maintain accurate headings for weeks at a time using only intermittent star sightings. They'd take a precise fix whenever the sky was clear, then dead reckon through any period of obscured visibility, constantly updating their position estimates based on speed, direction, and elapsed time. When stars became visible again, their dead reckoning position would be accurate within just a few kilometers. But the Bedouin sky wasn't just a navigation tool. It was a calendar, a weather station, and a survival manual all written in starlight. Different stars announced the seasons for travel, for finding water, for avoiding the worst heat. The appearance of certain constellations meant it was time to move camp before water sources dried up. Others signaled when to expect rain, when sandstorms were brewing, when the desert would become temporarily hospitable or permanently deadly. Caltharea, the Pleiades, marked the beginning of winter rains when it rose before dawn in late autumn. Al-Jawza, Orion, announced the coldest nights of the year when it dominated the southern sky. Al-Shurare, Al-Yamaniya, Sirius, warned of the scorching summer heat to come when it first appeared in the pre-dawn sky. Each star group carried not just directional information, but survival intelligence about what the desert would demand in the days and weeks ahead. The system was so precise that Bedouin navigators could predict their arrival times days in advance. They knew exactly when they'd reach water sources, when they'd need to alter course for seasonal grazing, when weather patterns would force them to shelter in place. The stars weren't just showing them where to go, they were showing them when and how to survive the journey. Suhail, Canopus, was perhaps the most important star in the entire system. Its first appearance each year, called the Rising of Suhail, marked the end of the killing summer heat and the beginning of the travel season. Caravans would wait for this single stellar event before departing on long journeys. When Suhail appeared on the southern horizon just before dawn, it meant temperatures would begin dropping, water sources would become reliable again, and the desert would transform from a death trap into a navigable highway. But the star calendar went deeper than just travel seasons. Different stars indicated optimal times for specific activities. When certain constellations reached particular positions, it meant the time was right for breeding camels, for harvesting desert plants, for collecting dew water, for predicting where flash floods might create temporary water sources. The navigators learned to read atmospheric conditions through stellar observations. Stars that twinkled excessively indicated turbulent air and possible sandstorms. Stars that appeared dimmer than usual meant dust or moisture in the atmosphere. Stars that seemed to shift position indicated heat shimmer that could distort other navigation readings. The clarity, brightness, and apparent movement of stars provided weather forecasting more reliable than modern meteorology in many cases. Modern GPS can tell you your position within meters, but it can't tell you that the star rising in the east means a sandstorm is approaching in 3 days. It can't predict that the constellation overhead indicates the oasis ahead will be dry this season. It can't read the dozens of environmental signals that the Bedouins gathered from their star observations, integrating navigation with weather prediction and survival strategy. The knowledge was holistic: astronomy, meteorology, geography, and survival craft all woven together into a single system. A Bedouin navigator didn't just know directions. He knew the desert's moods, its rhythms, its seasonal cycles, its hidden dangers and opportunities. He could predict not just where his caravan would be in 5 days, but what conditions they'd face, what resources they'd find, what challenges they'd need to overcome. The stars also served as a historical record. Major astronomical events, comets, eclipses, unusual planetary conjunctions, were remembered and associated with historical events. The appearance of a bright comet might be linked to a particular battle, a severe drought, or the founding of a new trading route. These celestial markers provided a way to date events and maintain oral histories across centuries. The system was so comprehensive that it included backup navigation methods for every possible scenario. If the primary navigation stars were obscured, secondary stars provided the same information. If all bright stars were hidden, faint stars invisible to untrained eyes could still provide direction. If the entire sky was covered, the position and movement of the moon through clouds could indicate direction and time. If even the moon was invisible, the direction of Mecca could be determined through accumulated stellar observations from previous nights. For over a millennium, this system guided caravans across the Arabian Peninsula, the Sahara, and the Syrian desert. No instruments, no maps, no backup technology, just human observation refined into near-perfect precision. When European explorers arrived with their compasses and sextants and chronometers, they found that Bedouin star navigation was often more accurate than their mechanical tools, more reliable in extreme conditions, more adaptable to local circumstances. The stars belonged to everyone who looked up. But reading them, truly reading them, understanding their language, using them to survive in the world's most unforgiving environments, belonged to the desert people who had spent generations learning to speak their ancient tongue. In the vast emptiness of the night desert, surrounded by sand that could shift and change without warning, they were never lost. They were always exactly where the stars said they should be. And the stars, turning overhead in their eternal dance, carried them safely home across the endless dark.